This video is a review of Lesson 78 as well as continuing forward with a few more examples and a little more explanation. So Lesson 78 was graphing rational functions. So real quick here, remember that a rational function, when we hear rational, we should be thinking rational numbers. So a rational number is any number that can be expressed as a fraction where the numerator and denominator are both integers, but the denominator is not zero. So with a rational function, this is a function that can be written as a rational expression, so as a fraction. However, this is going to mean that we're going to have a variable in the denominator. So remember, we found excluded values here. So denominators cannot equal 0. So if we want the excluded values, then we know that 3m minus 12 cannot equal 0. We solve this just like an equation to find out that m cannot equal 4. In this equation here, same idea, the denominator cannot equal 0, so x minus 8 this time cannot equal 0. Solve just like an equation. Therefore, the excluded value here is 8. X cannot equal 8. When it comes to graphing, rational expressions are related to inverse variations. So if we have the inverse variation y equals 2 over x, then we know that if I stick a 1 in, so 2 over 1 would be 2, and because inverse variations have a constant product, then that means we can switch the two numbers around and it'll still have the same value, the same constant value. So if 1 comma 2 is a value, then 2 comma 1 also is. We can also negate both of these so that we could also have negative 2 comma negative 1, or we could have negative 1 comma negative 2. So using that idea, we were able to graph out several points to see the curve here of our inverse variation. Now, these two curves here, remember, will approach the y-axis and the x-axis, but never cross them. That's why they're called asymptotes. So an asymptote is a line that the graph will approach, but never cross. Over here, in red, remember we graphed this, but we exchanged x for x minus 8. So x minus 8, by subtracting 8 here, this means that the x values will have to be 8 larger than they used to be in order to produce the same effect. So putting a minus 8 here, it's counterintuitive, actually has the result of shifting the whole thing over in the positive 8 direction. So 8 to the right. So 8 units to the right here, we find our new vertical asymptote. Since all we did was go left and right, that means the x-axis will still be our horizontal asymptote. And then basically this graphs the same way. So since this is over 2, if we can pretend like this is our new origin, you could look for constant products that come together as 2. So 1, 2, 2, 1. Negative 1, negative 2, negative 2, negative 1. Now, we talked about that, but in case that was just a little too confusing for you, another option here is actually just to go ahead and make a function table. So if I have y equals 2 over x minus 8, 8, you could just make a table of values here. So I might start with the point x value 9, because 9 minus 8 will come out as 1, and then 2 divided by 1 is 2. I might choose the value 10, because then 10 minus 8 is 2, and 2 divided by 2 is nice and easy, that's 1. I might choose 8.5, because 8.5 minus 8 would be a 0.5. So if you divide something by half, that's the same as multiplying by its reciprocal. So this will actually be 2 divided by a half, or 2 times the reciprocal of a half, 2 times 2. So that actually produce 4. I could go with 12, because then 12 minus 8 would be 4, and 2 over 4 is just 1/2, or to be consistent, I'll go with 0.5 there. So those are some options there for that one. Those are all going to the right of my asymptote at 8. So now we could go to the left sum. So I could go 1 unit to the left and go with 7, because 7 minus 8 would be a negative 1. 2 divided by negative 1 would be a negative 2. I could also go 2 to the left, and so I would have 6. So 6 minus 8 would be negative 2, and then 2 divided by negative 2 would be a negative 1. And then we could keep going. So 7.5 would produce a negative 0.5 or negative half. So that would actually produce a negative 4. If I were to go down to 4, so then 4 minus 8 is negative 4. 2 over negative 4 is a negative 0.5. And if you graph these out, what you're going to find, I'll pause there for a second for you to kind of take those in. But what you'll find is basically the points that we have here. Okay, so if you don't follow the shortcut of treating this like the new origin and looking for constant products that add up to our constant 2 there, or multiply to our constant 2 there, you could just make a table of values and find some points that work till you can see the curve. We're going to flip over now. And so in general, what we see here is we have the formula for a rational function, which is y equals a over x minus b plus c. And remember, ladies and gentlemen, that the minuses and the pluses really matter here. So when we see a minus, this means that in order to find what the value of b is, we have to think about this as subtraction. So if we see a minus 2, we know that b really is 2. But if I see a plus 2, then we need to think of that as subtraction. So plus 2 would be the same as minus a negative 2. So b would actually be negative 2 in that case. So we got to be aware of that. We got to think of this as subtraction to find the value of b. In the formula, though, the formula says plus here for c, which means we need to think of this as addition. So if we see a plus 3, then we're going to think of this as really c is 3. If we see a minus 3, well, that's really plus a negative 3. The asymptotes will shift based on b and c. So the vertical asymptote, remember, this is, again, counterintuitive. A vertical line is actually of the form x equals a number. Because if the x value has to always be the same, well, that's going to be a vertical line. So x equals b, and that's where we got to remember, we got to think of that as subtraction. So x equals b will be your vertical asymptote. Your horizontal asymptote will be y equals c, because a horizontal line will be y equals a number. So in the case that we did down here, our asymptotes, it turned out, so we're going to think of this as subtraction. So a plus 2, remember, is really minus what? Well, minus a negative 2. That means that b is really a negative 2. We're going to think of this because of the formula. The formula says plus c. So we're going to think of this as plus. Well, it is plus. So c is 1. So your vertical asymptote is x equals negative 2. So over here I'm going to find where x is negative 2, and I'm going to put a vertical line through that. And then my horizontal asymptote will be y equals 1. So I'm going to find where y equals 1 and put a horizontal line through that. Now remember, the asymptotes are not actually part of the graph. These are just lines that our graph is going to approach but not cross. So we don't do these with solid lines, we do them with dashed lines. From here, we can just find values that work. So again, you could make a table of values, or you can treat this as if this is our new intersection. Okay, pretend. It's not really, but pretend that's your new origin. So this time your k would be 4. So that means we're going to look for things that have a constant product of 4. So if this is my new origin, pretending, so 2 comma 2. 2 times 2 would be 4. For that matter, negative 2 times negative 2 would be 4. 4 times 1 would be 4. 1 times 4 is 4. Negative 4 times negative 1. Negative 1 times negative 4. And so on, and so on, and so on. Looking at a table of values, though, give me a second, erase my board there, okay. So if we look at this from the perspective of a table of values, I gotta remember, what did I write there? So y equals 4 over x plus 2 plus 1. If I make a table of values to find these points, Then what I'm going to do is I'm going to think about, okay, I'm going to add 2. So what could you add 2 to so that way this fraction is going to come out nicely? So, well, maybe I add 2 to it, because then 2 plus 2 is 4, and 4 over 4 is 1, plus 1 is 2. So that's an option. I could choose 0. 0 plus 2 is 2. 4 divided by 2 is 2, plus 1 is 3. We could choose, let's go with, let's see, what do I want to go with? Let's go with 1, or excuse me, negative 1. So negative 1 plus 2 would be a 1. 4 divided by 1 is 4, plus 1 is 5. So if we match this up then with our graph, sure enough, those pan out, right? We have 2, 2, so 2, 2 was a point. 0, 3 is another point. And then negative 1, 5 is a point as well. So table of values will work. But if you can get the shortcut of just pretending that this is our new origin with a constant product of this numerator, constant product of 4, that'll be a nice shortcut that'll be a lot faster. So at this point, I'd like you to please pause the video and grab your books, and I'm going to ask you to open up to page 513. Again, that's page 513. We're going to take a look at the practice problems. So I'm just going to kind of section this off here, and we'll go back up here to look at the practice problems. A, B, and C ask us to find the excluded values. So with A, we see y equals 4 over 6m. So remember, it's the denominator, 6m, that cannot equal 0. Well, divide both sides by 6. M cannot equal 0. So your excluded value is 0. B, we have y equals 6m over m plus 2. The denominator there is m plus 2. So m plus 2 cannot equal 0. Solve that just like an equation. Subtract 2 on each side. M cannot equal negative 2. So negative 2 is our excluded value. You can have every value of m but negative 2. C, y equals m minus 3 over 4m minus 8. So 4m minus 8 is our denominator, and that cannot equal 0. So I'm going to, you know what, I'm going to see here that 4 and 8 are both divisible by 4, and technically so is 0. So I'm going to break the rules a little bit on this one just because I can. And I'm going to divide by 4 first, just to take this opportunity to remind you, if you choose to go this route, we must distribute our division over addition and subtraction. So if we choose to do this instead of our typical add 8 to both sides, we're going to have to distribute the 4 over here. So 4m divided by 4 will be just m, and then 8 divided by 4 will be 2. 0 divided by 4 is 0, and there's our result. So now we're going to add 2 to both sides, and therefore the excluded value is 2. So there's our excluded values. D, we have to identify the asymptotes. So in D, y equals 4 over x plus 1. So if we consider that right there, I'm going to put this in red here, y equals 4 over x plus 1. So remember in the formula, it's x minus b. So we have to think about this as subtraction. So what's b here? Well, x minus what would be the same as this? Well, since it's a plus a positive, that means it comes from minus a negative. So this must be that b is a -1. And then over here, c, well, it's missing. So if we don't see it, plus what would be the same as not doing anything at all? Well, obviously that would have to be 0. So therefore, for D, our asymptotes, our vertical asymptote will be x equals -1. Our horizontal asymptote, we'll abbreviate it that way, our horizontal asymptote will be y equals 0. For E, likewise, I'm going to go ahead and write this with my red pen, just so we can see the thinking later. So we have y equals 2 over x plus 7, and then plus 6. In this case, remember, x minus b. So we got to think of this as subtraction. So a plus 7 would be the same as minus what? Well, plus a positive is the same as minus a negative. So this is really b equaling a -7. This here, then, it is plus c. So if we think about this addition, what are we adding? Well, we're adding 6. So c is 6. So in this case, my vertical asymptote is x equals a -7, and my horizontal asymptote is y equals 6. So moving on to F. Looking at F, we see y equals 6 over x plus 4. So we need to identify the asymptotes, and we need to graph the function. So this time we have y equals 6 over x plus 4. So I'm going to go a little faster than I did here this time. So looking at that, my vertical asymptote, we're going to have vertical asymptote at wherever b is. So the denominator there says x plus 4. So plus 4 is the same as minus what? Well, minus a negative. And then my vertical asymptote here, well, I don't see a plus c. Well, if we don't see it, that means that c must be 0. Adding 0 is the same as not doing anything. So those are my two asymptotes. So I'm going to plan ahead a little bit. With this centering around -4 and 0, it means that when I draw my coordinate plane, so I'm going to draw my x-axis to start with, because this is the x-axis. Y equals 0 is the x-axis. But then a -4 means we're going to be more on the negative side than we are on the positive side. So what I'm going to do here is I'm just going to throw my my y-axis over there. So x-axis is an asymptote, but then my vertical asymptote goes through here at x equaling -4. Now, the function says y equals 6 over x plus 4. So if we treat this like an inverse variation, this means that we would have a constant product. So if this is my pretend origin, we have a constant product of 6. So what times what gives me 6? Well, 2 times 3 gives me 6. And 3 times 2 gives me 6. For that matter, -2 times -3 gives me 6. And -3 times negative 2 gives me 6. Also, 1, 2, 3, 4, 5, 6 times 1 gives me 6. And then I don't have a ton of room here, but 1 times 2, 4, 6 gives me 6. And I feel like I got enough there to kind of follow the curve. Down here I need a little bit more. So let's go with negative 6 times negative 1 would give me 6. And negative 1 times 2, 4, 6, negative 6, would also give me a 6. And we'll draw our curve in with the space that we have. And that's my graph. So one more time here, if we treat this like the new origin, then that numerator can be our constant product. All right, let's tackle G, and we'll call it quits after G here. So G says y equals 1 over x minus 6, then minus 5. So in this case, my vertical asymptote will be x equals b. So remember, for the denominator, we think of it as x minus b, so it's minus. Well, the denominator there says x minus 6, so what are we subtracting? Well, this time it's a positive 6. And then it says minus 5, but we need to think of this as plus c. So a minus 5 is the same as plus what? Well, plus a negative 5. So my graph here is going to center on x being 6 and y equaling negative 5. So we want to kind of engineer things so that that's going to be in the middle. So with x being, or the horizontal asymptote, excuse me, being negative 5, I kind of want negative 5 to be in the middle, which means that I'm going to have my x value, or my x-axis, excuse me, somewhere up here. And then since our vertical asymptote is going to be x equals 6, I kind of want x equals 6 to be more or less in the middle. So I'm going to come over here pretty far. Make that look a little nicer. So vertical asymptote where x equals 6, so 2, 4, 6. Right here's my vertical asymptote. Y equals negative 5, so 2, 4, negative 5. That'll be my horizontal asymptote. And now if we look back at the function, that numerator, that if we were to get rid of the minus 6 and the minus 5, and think about this as an inverse variation, our k there would have been 1. So we're going to treat this as our new origin, and we're looking for a constant product of 1. So, well, 1 times 1 is 1. Negative 1 times negative 1 is 1. Okay. I might also go for 2 times a half, or a half times 2. And of course we can make those both negative. So a negative 2 and a negative half, or a negative half times a negative 2. I really want more than just 3 points on each side here, so we'll go with one more quadruplet, we could say. So let's go with 3. So 3 times a third is 1. A third times 3 is 1. Down here, negative 3 times negative 1/3 is 1. And a negative 1/3 times a negative 3 is 1. And we can certainly see the curve now. And there's my graph. And that, ladies and gentlemen, is the end of lesson 78.